All right, good afternoon, everyone. Welcome to the Bulkley Valley Research Center seminar series. Today, we are really excited to host Nick Reynolds and Bruce Blackwell. They're speaking on the Forest Practices Board document that's come out on forest and fire management in BC. Nick has a master's in sustainable forest management and an RPF, and he's worked for First Nations, industry, government, and academia and wildlife biology, silviculture, land use planning, timber supply, and others across Canada. His current focus is on the competing and complementary policies and practices between forest and fire management. I imagine that will keep you busy for another 25 years or so, Nick. And Bruce Blackwell has more than 33 years experience as a professional forester and a biologist, primarily focused in fire and forest ecology, forest management, fire management, the WUI interface planning, forest policy, audits and reviews. Bruce is considered a provincial expert in fire and fuels management and has managed numerous innovative projects related to fire risk identification and mitigation for both the public and private sectors. And again, we're thrilled to have you both join us today and really looking forward to your presentation. Thank you so much.
Thanks, Dawn. So thanks for having us. My name's Nick Reynolds. I'm joining you from the traditional territories of the Lekwungen people in Victoria. And we're going to just dive in. Our presentation probably should take somewhere in the order of 30 minutes or so, and hopefully we leave room for discussion. So just briefly about the Forest Practices Board. So we are BC's independent watchdog on forest practices, part of the provincial tribunal system, which performs adjudicative and regulatory functions as a part of the public justice system. We have the authority under the Forest and Range Practices Act and Wildfire Act to carry out audits, investigate public complaints, initiate special projects, and appeal determinations to the Forest Appeals Commission. So we started planning to write a report about landscape fire management, but quickly realized that in order to be successful, there are policy issues that need to be resolved. So we ended up publishing two reports, a special report and a technical bulletin. The special report addresses the need for provincial leadership and a vision to direct and align provincial policies. The technical bulletin speaks to land managers whose activities have a direct bearing on the health of BC's ecosystems. It summarizes the principles of landscape fire management, which will be largely the focus of today's conversation. We sort of tailored this webinar for more practitioners. All of this work, both the special report and the technical bulletin, is based upon interviews, experience, and knowledge that was shared with us by a diverse group of more than 30 experts from across BC, Alberta, and the US Pacific Northwest. And it included forestry practitioners and fire practitioners, social scientists and experts in fire ecology, fire behavior, modeling, and Indigenous fire stewardship. So the chair of the board can choose to do a special report on a topic that's in the public interest. This report was the first in a series of reports about wildfire. The board chose this topic to move the dial on forest and fire management toward the goal of managing for resilient forests. This aligns with the board's strategic priority of encouraging forest and range policies and practices that are adapted to climate change effects and support ecological resilience. I'll pass it off to Bruce.
Thanks, Nick. And thanks for listening in today. My name is Bruce Blackwell. I think most of this audience should know that fire suppression policies over the last century have had a resulting decline in fire frequency, So today, many of our ecosystems are in a fire deficit. And as a result, we have areas of deciduous forest, meadows, grasslands, and sparsely treed areas that have diminished over time as these fuels have encroached the landscape. And these high fuel loads, combined with the shift from a mosaic landscape to a more homogeneous landscape, have increased the vulnerability of landscapes to uncharacteristically high severity, large fires, catastrophic fires, we could say. And forest management approaches have also influenced the pattern and distribution of fuels, whether it's through clear-cut silviculture systems, reforestation, and free-growing policies, and the elimination of broadcast burning as a treatment option. All of these have resulted in a more homogeneous landscape. These fire and forest management policies have also interrupted and excluded Indigenous fire stewardship. So throughout history, we know that many Indigenous people use fire as a tool to manage lands to achieve specific objectives, and those are cultural and ecological. And cultural burning was generally applied during low-risk periods, and as such, early spring, late fall, and cultural objectives included increasing the abundance of preferred resources such as berries, medicines, forage, and game species, promoting desired landscape conditions such as fuel breaks to protect their communities, and contributing to a symbolic and sacred relationship from with humans and nature benefiting from fire. So I put this graphic together a few weeks ago for the Natural Resource Forum, just to emphasize the point that over the last 4 decades, we've been in an increasing trend in the area burn. And if you follow the climate science, there's quite a good climate change and fire publication that was created in about 2005 by Flanagan et al. And the primary climate change driven change that was expected is that the area burn was to increase dramatically over time. And I think looking at the trends of area burned over the last 4 decades, starting in the 80s and 90s, we can see that we're now on both an exponential increase in the area burned, and that the number of wildfires that burn each year are trending upwards in a very significant way. And so the combination of the two is having broad impacts across the land base. Next one, Nick. So just a couple of historic photographs. This is from Washington State to show this change in homogeneity, or what was a heterogeneity landscape at the top to a more homogeneous landscape in the bottom, how the fuels have encroached, and how there are not a lot of barriers left where fire can't go. And this is a classic example published in the literature, these types of examples, and they've been frequently published over the last 20 years. And here's another example. Next slide, please, Nick. In Waterton National Park, and this one is interesting in that it shows different patterns of fire. You can see on the left the encroachment of tree cover into the landscape, and on the right you can actually see the fire patterns. Upper slide, the black and white on the right shows some historic fire on the landscape with the gray trees, and then you can see the more recent fires of, I think, 2021. And this is part of what they call the Mountain Legacy Project, where they're trying to document these types of changes in fire patterns on the landscape. Next slide. It's well documented in the Provincial Strategic Threat Analysis that's been conducted by the BC Wildfire Service that as of 2021, 45% of public land in BC is in a high or extreme threat to wildfire. So we know that this is a wide-reaching and expansive problem. Next slide, please. We also know that the consequence of catastrophic wildfires are broad. There's been some research in the US that suggested that the multiplier effect of dollars spent on fire suppression ranges between 2 to 30 in terms of its multiplier effect. We know that wildfire smoke impacts our physical and mental health. Wildfire suppression costs have been steadily increasing over time, costing up to $1 billion in specific years. And the indirect costs from wildfire, as I said, are 2 to 30 times higher. Forests are considered to be also one of the best sequesters of carbon. And if we want our ecosystems resilient through fire, we need to remove the buildup of fuels and the carbon, and that carbon to cool the landscape. The historical fire disturbance regimes of BC ecosystems are based on fuel levels and ecological conditions that could absorb and recover after fire. However, with the current high fuel loads and changing climatic conditions, catastrophic wildfires will likely push some ecosystems beyond recovery thresholds. In other words, the fire severity will be so high that the recovery of those ecosystems to their historic condition is potentially unlikely, or the effects are very long lasting. Next slide, please. The scope and scale of this problem is so broad, and the dollars that we have to invest in it requires us to think strategically about how can we manage the landscape to limit the scope and scale of some of these large fires. And so part of what we tried to document in this report is how, as practitioners, do we think about landscape fire management as part of the solution. And landscape fire management is an ecosystem-based practice of managing fuels and landscapes to achieve specific objectives, such as restoring a mosaic of forest conditions or reducing catastrophic wildfire. And going back to that slide about area burned, really the key focus that we need to work on is finding a way to redirect that curve downward so that the area burned is minimized. Or we're practicing fire during those periods, we're introducing fire during those periods of spring and fall where the impacts of fire aren't so severe. Landscape fire management is an integrated and interdisciplinary approach. It is implemented both through Indigenous fire stewardship and at an industrial scale, integrated into planning and the business cycle of the forest industry. So I think that's important, and we can be thinking about introducing it into the energy sector and into protected areas management. I think it's key, and one of the points that we made in this report is that protected areas are as vulnerable or more vulnerable to fire moving forward, and if we expect to keep them in the present condition, they're going to require some form of protection or fuel management. To help illustrate landscape fire management, imagine a landscape as a box. The edges are areas of low fuel, either human-made or natural, that can help to contain or slow wildfires. And inside are forests and the many values they provide. Landscape fire management initially focuses on modifying fire behavior at the edges of the box by treating a small portion of the landscape to affect the size and impact of fires when they occur. We already know there are lots of features in the landscape, whether they're riparian areas, rivers, ridges, rock outcrops that act as barriers to fire. We need to think about tying those together in landscapes so that we create an opportunity for firefighters to stop fire. It's safe for them to fight fires there. They can backburn in some of those places. And ideally, we're reducing the risk on parts of the landscape so we can begin to reintroduce prescribed fire, because as we've talked about earlier, this is such a big fuel hazard that without some form of fuel removal, reintroducing prescribed fire is going to be difficult. So the first step is treating the edges, looking at the landscape with containing fire within specific units. And a long-term goal of landscape fire management is to treat inside the box. So first of all, we establish the edges, and then we can begin to safely start chunking off parts of the inner workings of the box to restore the entire unit. That includes a distribution of treatments, including fire, over time and space, to achieve a mosaic of ecosystems that are resilient through fire. The combination of these successional stages and fuel conditions determines the diverse pattern of future fire behavior and severity, which we really need to get control of. The next slide highlights some projects that are ongoing, and this isn't an exhaustive list of all the projects that are going, but currently there's landscape fuel management being practiced in a number of community forests: Burns Lake, Whistler, Harriet Proctor, and Nelson. The Caribou District in 2015 did a big landscape fire management plan that identified where and the scale and size of fuel breaks that needed to occur to protect areas of the WUI within that landscape. And there also is a similar plan in an LFM plan in the Rocky Mountain District. So landscape management is already being practiced at the planning stage, at the implementation stage, and actually there are a number of completed landscape fuel management projects throughout the central and southeastern part of British Columbia. So I'll turn it over to Nick. You're muted, Nick.
Thanks. So we heard from a wide range of wildland fire experts over the course of the project, and many themes came to the surface. And several of them were practical for implementing landscape fire management. So this technical bulletin that was published was meant to add to the conversation to help promote the integration of forest and fire management in BC. The first was really around defining the landscape. So similar forest and fuel types can span uninterrupted across woodlots, private lands, tree farm licenses, or municipal boundaries, protected areas. Wildland fire rarely follows those boundaries. Firesheds is a term readily used south of the border, and they're planning units whose boundaries are informed by wildland fire behavior. Fire containment or control features make up the edges, like Bruce was mentioning, natural low fuel like wetlands or water bodies, or topographic features like ridgelines, ecological transitions like grasslands or alpine. But these boundaries also consider man-made low fuel areas, such as agricultural areas or existing road, rail, or transmission corridors. They also consider tactical wildland fire suppression factors like access. These units range up to the tens of thousands of hectares. They might be nested into or complement existing planning boundaries, such as this example in BC's southern interior, which is just being used for illustration purposes only. So defining this landscape is a foundation for cross-boundary collaborative fire planning. It helps integrate suppression and prevention activities with common wildfire objectives across jurisdiction and resource sectors. So how do we expect wildfire to move through our landscape? What type of fire do we expect? How big might they be? How often might they occur? How fast might they spread, and in what direction? Well, these questions have predictable answers. We can look at past fire patterns. So for example, when was the last time an area burned? This illustration shows large fires from the 20s and 40s, but almost no fires since. We can talk to Indigenous stewards and traditional and local knowledge keepers about the role of historic fire. We can look at ignition patterns. Where do we expect lightning or human-caused ignition? This is all part of understanding the current and projected conditions for our landscape. We can look at fire weather, such as seasonal trends in precipitation. This graph here shows a nearby weather station with the decrease from baselines. The baseline was from 1980 to 2010, decrease in precipitation during the fire season compared to the recent decade. We can look at temperature. So in this case, that peach color represents the local baseline of 90th percentile. So that's, in other words, variables like relative humidity or temperature or fuel moisture is higher than 90% of the observed values in a specified period. And you can see how it's in the last decade, how we're going beyond that, or we're in that 90th percentile from the baseline. We can look at wind direction during the fire season, as well as local trends in fire danger rating days. We can look ahead at climate change models, which gives us insights into how fire weather may change over future decades. Climate and geography and fire history, they all provide clues into how to expect wildfire to behave in our landscape. In BC, we have the natural disturbance types classification, which are divided into 4 classes. And the area that we have here shows 3. The low-lying areas would have seen frequent stand maintaining fire, like ground or surface fire every 2 to 50 years. The mid-slope area, which would be kind of that reddish area, would have seen frequent stand initiating events. So mixed surface and crown fires maybe every 150 years. And the highest elevation, that blue, may have only seen infrequent stand replacing events like crown fires every 200 years or so. So these just represent bookends across a gradient of fire severity and frequency that describe a wider range of fire regimes. The Canadian Forest Service has about 14 fire regime types described for BC. Understanding fire regimes, they're important to land managers like foresters because they hold important clues pointing to forest attributes, how patch sizes, biological legacies like coarse woody debris or stand structure or species distribution, they all will differ across these fire regimes. Understanding them helps us manage for them and make landscapes more resilient. So lastly, we can look at patterns created by natural disturbances. We looked at this as the fire history, but we can also look, of course, at harvest history and other patterns of vegetation, which, of course, collectively, these patterns make up our fuel types. So Canada's forest fire behavior prediction system can be used with our forest inventory data to estimate fuel types. Like, for example, ponderosa pine Douglas fir, which is dark green in this map, or deciduous or mixed wood fuels, which are light green in this map. So together with the fire weather, topography, and these fuel types, they can all be used in fire behavior modeling. So this is an output example of what's called a head fire intensity model, which shows the expected energy of a fire line based on those fuels and topography. So with fire behavior modeling, we can begin to understand the hazards. So how much has the landscape departed from, or is it approaching resilience through or to fire? But the next principle was about understanding the risks to the values. Where must we minimize adverse effects? Where is fire accepted or prescribed to promote its beneficial effects? So there's no comprehensive wildland fire risk framework in Canada. In BC, we use what's called the Resource Sharing Wildfire Allocation Protocol, which helps define priority levels, primarily for suppression response. And that starts with human life and safety, of course, concentrating efforts around communities, and then critical infrastructure like transmission lines, pipelines, communication towers. But that typically leaves other values like high cultural or environmental values and other resources out of the prevention suppression planning. For landscape fire management, we extend it beyond the wildland-urban interface. We want to include regionally important values, whether that's community watersheds or traditional use areas, wildlife habitat or old growth forests or merchantable green timber. These are just examples of other values you can start planning for. And then, of course, knowing the spatial location of these values and the fire behavior modeling provides the consequence and hazard factors that can be used to determine the risk. This can be done through landscape level threat assessments, and it's not unlike the Provincial Strategic Threat Assessment that the Wildfire Service undertakes for the whole province, which is a great start. Right now, it just focuses on those high priority RSWAP values like structure density. So next, we move to setting complementary wildland fire objectives. We have a sense of the risks. How can objectives extend across jurisdictions where everyone's on the same page? And this means objectives can be set on a gradient of intervention. And it should spatially consider specific fire behavior outcomes. So some areas will require active risk reduction, such as right around communities. We don't want these areas to burn. Or through catastrophic wildfire. There's already a lot of this work going on, of course, but this may be extended beyond the interface to places like community watersheds or other values that we discussed. And then there is moving closer, across the spectrum towards passive management. Other areas may be managed just to minimize unplanned fire. So limit potential fire behavior, provide wildfire response decision makers with a broader range of options to minimize adverse effects and maximize beneficial effects of fire. And then other areas may emphasize a restoration of fire to the landscape. There's a lot of examples, such as Parks Canada through Banff, Jasper, and Yoho National Park, using historic fire regimes across varying ecoregions as a reference for fire type, size, and frequency. And they will calculate the expected annual area burned and then assess annual targets for intervention based on that. Just speaking to the active side, not so much the passive strategies, it really is about either converting, reducing, or isolating fuels. And in terms of converting fuels to less flammable fuel types, some strategies that people are well aware of, they might not be, you might not be applying them everywhere. This is an example of what could be a landscape level fuel break. In the community, you can see on the left-hand side of the fuel break might be where you establish fire tolerant stands. So that might be, for example, lower densities, more fire resistant or resilient species, including deciduous trees. You might be designing in those areas low flammable retention, particularly for in-block reserves. We'll be managing surface fuel loads and the different surface fuel loading targets in different areas, obviously. So we'll do that through mechanical or hand treatments, or thinning or targeted harvesting. So that will reduce fine fuel loads to specific targets, whether it's inside or adjacent to low fuel corridors, but it's informed by the fire behavior outcome that we're hoping for. And so this is done through biomass utilization. It could be done through piling or pilot burning, or of course the use of prescribed fire. In treated stands, research in the US has found that the most effective way to reduce surface fuel was a combined approach using mechanical fire treatments and prescribed fire. And of course, adding to the active strategies that we have are, of course, increasing crown base heights or reducing crown fuel load. So thinning the overstory to lower the risk of an active crown fire. And of course, lastly, there is just isolating fuels. So this could take the form of primary or secondary fuel breaks. It could include full vegetation removal, as discussed earlier, or using these various strategies as shaded fuel breaks. So it's the at the end of the day, these fire behavior outcomes require things like road locations, or for forestry, cut block shape, size, retention, and regeneration should consider fire regimes, fuel types, values at risk, the post-treatment fuel loading, and fire behavior potential. And it means that policies need to align to enable landscape fire management.
So I think in thinking about this, LFM is an iterative and ongoing process that's periodically updated to recognize changes in infrastructure, forest harvesting, natural disturbance, vegetation succession and growth, and how fuels are affected over time. It's not a cookbook. There isn't a way to sort of look at this and there still is a lot to learn. We don't know the efficacy of many of our treatments. We have some good science that we hope that will put it in the right pattern, but certainly we need to understand how our manipulation of fuels, whether in size classes, whether it's objectives to reduce crown fire, whether it's prescribed fire, we have a lot of learning to do because we have a complex ecosystem in British Columbia. We have many different ecosystems where fire has influenced things in different ways. Next slide. There is a lot of work that's been done looking at fuel treatment efficacy, and the report that we pulled together has a fairly exhaustive list of publications that have recently been published as it relates to fuel management that's applicable to British Columbia. Next slide. So really the take-home messages here from the work that was done to put this board report together is that we need leadership, a vision, and a coordinated and collaborative action plan. There's lots of things going on in fire management in BC right now, but unfortunately they're not all going in the same direction. Whether that's licensees, whether that's practices, we're still creating fire problems through some of the things that are going on in the landscape. And ultimately, the pace and scale of action must surpass that of wildfires. I know Bob Gray and myself talked about, we had maybe 20 years to get our act together when Filmon was done in 2003. And I can say we've hit that 20-year window, and unfortunately, we didn't get enough done, and we need a lot to happen in a very quick way if we're going to avoid fire seasons like 2023, 2021, and the list goes on and on. And we need to integrate landscape fire management into the land management framework. We need to consider how the work we are doing can play a role in that implementation. Next slide. So we open the floor to questions. If you didn't read our report, I think the best way to understand this presentation is to read the full report. There's a lot of good things in there, facts, details, and then some comparative recommendations. So thanks for everybody for listening today, and we look forward to your questions.